Hi everyone, welcome to part 2 on our video lecture for section 3.7, dealing with the chain rule. In this video, we're going to be taking a look at more examples of the chain rule. So let's go ahead and begin with this first problem, where we're being given the function h of x is equals to the sine of 2x. Alright, so here we have the chain rule. Now let's go ahead and identify what's the inner function and what's the outer function. Now this is an example that you guys tried on the previous recording, and you probably got that the inner function was simply the 2x, and the outer function was the sine function. Now finding the respective derivatives here, g prime of x is just going to be a 2, and f prime of x is just going to be a cosine of x. Okay, now putting everything together here, what is the derivative for the h function? Well, we're going to get h prime of x is equals to the derivative of the outer evaluated at the inner times the derivative of the inner. And there we go. Now we have our derivative for h. Perfect. All right, now let's take a look at another problem involving the sine function. So we're given h of x is equals to sine squared of x. Perfect. So let's see, which one is the inner function here, the x? No, remember that when we saw the sine squared of x, this one here was the same thing as the sine of x squared. And now we get to see here that, oh yeah, the inner function was the sine of x. Then what was the outer function? The outer function was simply the square function, so x squared. All right, now let's go ahead and find the respective derivatives. As we said before, the derivative of the sine was the cosine, so g prime of x is the cosine of x, while the derivative for f was simply a 2x. Okay, so now let's put everything together into the chain rule to obtain our derivative for h. H prime of x is going to be equals to, again remember, it is the derivative of the outer evaluated at the inside, or the inner. So we're going to get here the sine of x. Now is raised here to the first power, because it's 2x to the first. Okay, times the derivative of the inner function, which in this case was a cosine of x. And there we go. And now we have our derivative for h. All right, now after we've been seeing a couple of problems here, hopefully the chain rule is starting to make more sense and it's becoming less scary. But the chain rule is one of the most applied rules. Now, I have another problem here where I decided to put on hold. Now, I was going to have you guys come up with a derivative for any exponential function, not just the natural exponential function, but let's go ahead and put this one on hold. We'll return to this one later, because for now, I want to keep on practicing with more chain rule problems. All right, so let's take a look here at more functions. Now these ones here are completely new functions. We haven't done them before, so we now have to identify again what's the inner function, what is the outer function, and what are the respective derivatives. Okay, so let's take a look. So we have the function f of x is equals to the square root of tangent of x plus for x. So this one here does look like it's a function composition. All right, so it's a function composed of which two functions, which one's the inner, which one's the outer. So for this one here, we get to see that, okay, it looks like my inner function is the tangent of x plus for x. And the outer function is the square root function, or just x to the 1/2 power. All right, now let's go ahead and find the respective derivatives. The derivative for g is going to be equals to, now let's see, what was the derivative for the tangent? Remember that the derivative for the tangent was a secant squared of x plus, now what is the derivative for x? Well, that's just going to be a 4. Excellent. Now, going to the outer function, the derivative of f is going to be equals to 1/2 times x to the negative 1/2. Okay, so now let's go ahead and put everything together here using our chain rule formula. Now, I did not write the chain rule formula again. I do trust that you guys write it though, because I want you to feel very comfortable with the chain rule formula. Okay, so let's take a look at this one here. So let's see, the derivative for f is going to be the derivative of the outer function, which was a 1/2 times x, but remember, it's the derivative of the outer function evaluated at the inner function, which in this case was a tangent of a tangent of x plus 4x. And this one here is being raised So the negative 1/2 power times the derivative of the inside, which was a secant squared of x plus 4. Now, what's wrong with my answers? Careful here. Don't forget parentheses. Okay, now last and final thing to do here is simplify it if we can. Now in this problem, there's not a lot of simplification that you can do, but I don't want to see the negative exponent right now, so I'm going to go ahead and bring the negative 1/2 power to the bottom to make it positive. So we're going to have then a 2 times the square root of tangent of x plus 4x. And on the numerator here we had the secant squared of x plus 4. And there we go. Now we have our derivative. Excellent. Okay, now let's take a look at another problem here. What about this function here, where we have g of t is equals to t minus 2 all over 2t plus 1, and the whole thing is being raised to the 9th power. All right, so this one here looks a little bit trickier because, well, not only are we raising some inside function to a power of 9, but the inside function itself, it's a division. So it looks like we might need to use both the chain rule and the quotient rule. So now you get to see here, guys, that, oh, look, we can't combine the rules. And the thing is, the chain rule is going to be the last major rule for differentiation that we're going to be seeing. The rest of the problems are just be combinations of products, quotients, and chain rules. Okay, so with that said, let's go ahead and identify what seems to be the inner function and what is the outer function. Well, we get to see here that the t minus 2 all over 2t plus 1 seems to be the function that's inside. So this one here is our inner function. So there we go. Here you have the inner function g. Now, again, emphasize this is not the same thing as this g. I decided to not include the t here just to hopefully differentiate it a little bit more, but yeah, these ones here, not the same. It's just the way that I'm labeling them here. Okay. Now, if the inner function was t minus 2 over 2t plus 1, then the outer function is just going to be f equals to t to the 9th. All right, so now let's go ahead and find the respective derivatives. And let's go ahead and begin with g. So what would be the derivative for g? Well, now you get to see here that this is where we do need the quotient rule. Okay, so what was the quotient rule? Now, I'm not going to go ahead and rewrite it again, guys, but I will identify the functions. So I'm going to put them in colors here. I'm going to go ahead and say that this one here is f, the numerator, and this one here, our denominator for g, which again, I also call g. If you want to call them different variables, that's fine. Because again, I want you to remember that, okay, what was the quotient rule? If it was two functions f over g, then the quotient rule was g. So we're going to have here a 2t plus 1 times the derivative of f, the top, which in this case is going to be just the 1 here. Let me go ahead and label them. This one here was g. This is f prime right here, minus the derivative of g, the denominator here, which in this case is just going to be a 2. So here's the g prime, times f, which was dt minus 2, and it was all over g squared. So put here 2t plus 1 squared. There we go. Now, can we simplify this one here? I think this one here looks nice and easy. So let's go ahead and simplify this one. All right, so on the numerator, I have 2t plus 1 times 1. So it's just going to give us here a 2t plus 1, then minus, well, 2 times t, and then 2 times negative 2 is going to become negative 2 times t will be a negative 2t, then negative 2 times negative 2 is going to give us here a plus 4. And it was all over the 2t plus 1 squared. All right, so to continue simplifying here, you get to see that on the numerator, I see a 2t minus 2t, so that's gone. But I do have a 1 plus 4, which is going to give us here a 5 over 2t plus 1 squared. Excellent. Now don't forget though, all of this was simply the derivative of the inside function. We haven't completed the problem. We still need to use the chain rule. Okay, so now let's go ahead and complete the problem using the chain rule. So the full derivative for the original function g prime of t is going to be equals to the derivative of the outer, whoops, we haven't done it, the derivative of the outer, f prime is going to be a 9t to the 8th. So we're going to have a 9. All right, so it's the derivative of the outer, evaluate the inner, and in this case, the inner was the t minus 2 all over 2t plus 1 being raised to the 8th times that derivative of the inside. And for the derivative of the inside, we ended up getting the 5 over 2t plus 1 squared. And there we go. Now we got the full derivative here. And again, this one here was a combination of the chain rule and the quotient rule. Perfect. Now let's see if we can practice with the combination of the chain rule and now let's say the product rule. So let's go ahead and take a look at problem 3 here, where we're given the function h of x is equals to x squared times e to the sine of x. All right, so let's take a look at this one here. You know what? Let's actually change this one here. Let's get rid of the sine and instead, let's go ahead and practice with, I don't know, a cotangent of x. So basically our function here is going to be equals to x squared times e to the cotangent of x. So we can practice with different types of derivatives for the trig functions. Alrighty, so this time around I have two functions. They are multiplying, so I will need the product rule, but the second function, the exponential, the exponent is not just an x, it's another function, the cotangent function. So this problem needs a combination of the product and the chain rule. Okay, so if we're going to be using the product rule, because it's a product here, okay, what are the functions that are multiplying? Well, I see an x squared, and I'm going to call this one here my f. And I see the e to the cotangent of x, so it's going to be my g. Okay, so let's go ahead and find their respective derivatives. The derivative for f is going to be a 2x. Now for the derivative of g though, well, notice that we have to be careful with this one because this is where we need the chain rule. So I'll put here the chain rule. I guess I'll do it here. All right, so what was the inner function? So we get for this one here, the inner function was the cotangent of x. And I'm going to call this one here my u. Again, do you want to call it a different variable? That's perfectly fine. Now, what would be the derivative of u? Well, the derivative of the cotangent, it begins with a c, so the derivative is going to be negative. So we're going to have negative. Now, what was the derivative for the cotangent? It's a negative cosecant squared of x. Perfect. All right, now, this was the derivative of the inside function. Well, what about the derivative for the outer function? Well, the derivative for the outer function, since it's the natural exponential function, then it's just itself. All right, so our full derivative for g then, g prime is going to be equals to the derivative of the outer evaluated at the inner, which was just the cotangent of x, times the derivative of the inner, which we said was a negative cosecant squared of x. All right, so putting everything together here into the product rule, which again, I'm not going to go ahead and write right now. I do trust that you guys are remembering them more now. All right, so what did the product rule say? Well, it said that it was the derivative of the first, which in this case here was a 2x, times the second function, g, which in this case was the e to the cotangent of x. There we go. Well, plus the first function times the derivative of the second, which in this case was e to the cotangent of x times the negative cosecant squared of x. All right, now this one I am going to simplify. For starters, I notice that I have an e to the cotangent of x on both terms, so I'm going to go ahead and factor out the e to the cotangent of x, and I also notice that, hey, well, this one here has an x, this one here has two x's, so I can also factor out an x from both. So factoring out the x and the e to the cotangent of x, we're going to be left with x times e to the cotangent of x times 2 plus x, well, because of the negative here, might as well multiply it, minus an x times the cosecant squared of x. And there we go. This one here should be our final answer for the derivative of h. And we're done. Excellent. Alrighty. Now again, make sure that you get plenty of practice using the product and the quotient rule, because as we got to see in these examples, we also will need to combine them with the chain rule. Alrighty. So let's see. For the next problem, I think this is a good one here to include in the discussion board so that you guys get to practice using the product rule with the chain rule. Okay, now I have a question for you guys. So far, we've taken derivative of functions compositions f of g of x, but what about multiple compositions? So for example, what if I wanted you to find the derivative for f of g of h of x? Can we take this derivative? Well, you bet. If we went ahead and took the derivative of this triple composition, then our derivative would have been f prime evaluated at the inside, which in this case is the g of h of x. Oops, it looks like I missed a parenthesis here. Okay, so this is part of the derivative times, okay, now we start working our way inside. Now it's going to be the derivative of g evaluated at the inside, which in this case is the h of x, times now the derivative of the inside, which is h prime of x. And there we go. This would have been the derivative for this triple composition. Okay, so let's go ahead and practice finding a derivative of a function made up of multiple compositions here. Alright, so let's take a look at the following function. Y is equals to parentheses sine of 3x squared plus e to the x, all raised to the third power. Okay, so let's practice. What would be y prime here? Alright, so y prime is going to be equals to, alright, so what seems to be the outermost function? Well, the outermost function is the function that's raising everything to the third power. Okay, so we're going to go ahead and take the derivative. We're going to have here, this one comes to the front. So we're going to have a 3 times, because remember it's the outermost derivative, evaluated at the inside, which is a sine of 3x squared plus e to the x. Now this one here should be raised to the second power, and I guess I'll put the function here, the outermost, would have been x cubed, so the derivative was 3x squared. That's what we have here. Okay, now we multiply it times the derivative of the inside. Now what is the inside function? So for the inside function, we have a sine of 3x squared plus e to the x. So the g function in this case would have been the sine of x with the derivative cosine of x. And the innermost function here, h, would have been the 3x squared plus e to the x, whose derivative would have been 6x plus e to the x. All right, so let's go back to our problem. So far, we have the derivative of the outer evaluated at the inside times now the derivative here for g, which it's a cosine of, now it's evaluated at h of x, which is a 6x, oops, I copied h prime, 3x squared plus e to the x times the derivative of the inside, which is the 6x plus e to the x. Now what would we be missing here? You got it. Don't forget. Gotta include parentheses here. And this is it. This would have been the full derivative for y prime. Alright, so this is where we're going to be stopping our recording here. We'll keep on practicing more problems involving the chain rule, both in class and in the next topic, which is going to be just, it's going to have a different name for the techniques, but it's really just going to be the chain rule. Alrighty, well, I'll see you guys there. Have a good one.